Hello everyone, wishing you all a very good morning and welcome to the class. I think in last class we were discussing the potential energy graph. We were discussing the various types of equilibrium. We had discussed three types of equilibrium: stable, unstable, and neutral. Now we'll go ahead and discuss more and finish this topic. If I remember, I had sent you the sheet, class notes sheet, and I asked you to draw the table of the three equilibrium, the three column wala table. Have you drawn that table in the notes? Everyone, please raise your hands that you have drawn the table. One, two, only two people. Three, four, five. Everyone, well done. Chalo, I'm very happy. If you have drawn that, then it's time that we move ahead and try to discuss more points and see what that table actually means. Let us have a look at what that table means. So I hope you have already drawn that table. So once you have drawn that table, it becomes easier for me to just make you understand what that table means. And I'll just lecture and you listen to it. And if you want, you can mark anything that you feel on the notes that you have written. So right now, types of equilibrium, that is what we were discussing that day. Types of equilibrium, and we have seen that there are three types of equilibrium. Now for any equilibrium to happen, whether it is stable, whether it is unstable, or whether it is neutral, one condition is common to all these three equilibrium. As soon as the word equilibrium comes, we must understand that equilibrium only happens when force is zero. When force or the net force acting on the particle is zero, I should not say force. There could be many forces acting on the particle, but the net force, if it is zero, then the particle has to be in equilibrium. Newton's first law then comes into the picture. The particle will continue its state of rest or state of uniform motion if the force is zero. Now force is zero now implies we are talking about conservative force here. Force is zero. Force is the negative gradient of energy. We are talking about conservative forces. We are not talking about friction. Friction does not have a field. So if we are talking about conservative forces, and if the conservative forces are zero, the derivative of that, the partial derivative of that energy has to be zero. So this condition, that du by dx is zero or f is equal to zero, is common to all the three equilibriums, whether it is stable, whether it is unstable, or whether it is neutral. I hope that point is already clear. Now let us understand and note the important points about these three. There are 4 or 5 points. If you can remember those 4 or 5 points, well, you have done exceedingly well. The first type of equilibrium that we should understand is known as the stable equilibrium. Now, what is this stable equilibrium? If you remember stable equilibrium was represented by a ball which is at the top of a bowl or bottom of a bowl or bottom of a hill. If you displace it from that position, it will go up, but it will always come back. It will go up, but it will always come back. Going up, come back. Going up, come back. So how do I write this? To write this, to understand this, this is written in this way. When a particle is displaced slightly from this position, which is the position of stable equilibrium, when a particle is displaced from this stable equilibrium, then a force starts to act on it. And this force tries to bring it back to the initial position. So as soon as I displace this ball from the bottom of the hill, it goes up the hill, a force will start to act on it, and that force brings it back to its initial position. This force is known as restoring force. Restore. It is restoring it. It is bringing it back to its original position. Now this restoring force or this stable equilibrium would be coming to you very soon in the chapter on SHM. I guess either gravitation or SHM will start, and then with the other sir. This force which is trying to bring the particle back to its original position is known as restoring force. It is bringing it back, restoring it. Something has changed. It has been restored, brought back to its original condition. This force is known as restoring force, and this type of equilibrium is known as stable equilibrium. So wherever you have stable equilibrium, one thing would be sure, that there would be some force which will be trying to bring it back to its original condition. That is the restoring force. That is the first point that we have understood about stable equilibrium. Stable equilibrium, there would be a restoring force. What about the unstable equilibrium? The second type of equilibrium marked in red is the unstable equilibrium. Now what happens in unstable equilibrium? If you go back to the previous class, you have a hemispherical bowl and you have a ball at the top of that hemisphere or hill. As long as it is on the top, nothing happens. It is in equilibrium. But as soon as I disturb it, it will just go down. Turr, turr. It will never come back. It has no tendency of coming back. So when a particle is displaced slightly from this position, then a force acting on the particle tries to displace the particle further. So basically a force will act. Force will definitely act. But that force will not try to bring it back. That force will push it away, push that particle away from that position. So that force is not restoring force. That is a pushing away force. We don't have a name for that. But force will act, and that force will make the particle move away. This type of equilibrium is known as an unstable equilibrium. Particle is unstable. It does not want to come back to its original position. It just wants to move away, go away, go away, go away. Now, there was a famous poem, and I think kindergarten, rain, rain, go away, come again another day. So unstable equilibrium is like rain, rain, go away. Just saying go, 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 don't come back. That is unstable equilibrium. The third type of equilibrium is known as the neutral equilibrium. So this is neutral. Now what happens in this equilibrium? This equilibrium is equivalent to something on a flat surface. When I displace it slightly, when the particle is slightly displaced from this position, then it does not experience any force. So here in this neutral equilibrium, the force still remains zero. The force is zero. So if I displace it even, there is no force acting on it. In stable equilibrium, the blue one, as soon as I displace it, force will try to bring it back. In unstable equilibrium, the red equilibrium, the force will act and will push it away further. But in neutral equilibrium, there is no force at all. There is no force acting on it, and it continues to be in the equilibrium position, in the displaced position. So if you displace it, it will just remain there. It will stay in equilibrium there. This type of equilibrium is known as neutral equilibrium. Three types of equilibrium explained in terms of what forces are acting on them. In case of stable equilibrium, restoring force acts, tries to bring it back. In case of unstable equilibrium, force acts, pushes it away. In case of neutral equilibrium, no force, it just stays where it is. That is the first difference between the two. What about the next difference? As you have already seen, stable equilibrium is represented by a ball at the bottom. And what happens at the ball at the bottom? The potential energy is minimum. Remember, everybody has a tendency to go to a position where the energy is maximum. Because if energy is maximum, then stability is minimum. So they are opposite of each other. When energy is minimum, and you will be coming across these terms, so that's why introducing this. Stability is maximum. You are only stable when you are at your minimum energy. See, you can take it practically as well. If you are tired, if you have no energy left, you will just stay where you are. You will just be sitting at your place doing nothing. But if you have a lot of energy, my kid, 6 year old, 7 year old, he has a lot of energy. He does not sit at one place. He'll just keep on moving here and there. Once he get tired, he has less energy. He will just stay where he is. Minimum energy, maximum stability. That is the main point about stable equilibrium. You have less energy, you will stay where you are. You will try to come back, okay, to that position where you have minimum energy. Okay, let me have minimum energy. I will have maximum stability. What about the red one? It is at the top of the hill. So this is where you have maximum potential energy. You are at the top of your career. There's only one way that you can go there, that is down. And you are very scared, because you are at the top, someone will displace you. That is why your stability is minimum. So you must remember this. Stability is minimum here. Energy is maximum, but stability is minimum. As long as you are there, you are there. If someone displaces you, you will just fall down. Stability is minimum when energy is maximum. Stability is maximum when energy is minimum. What about the green one, the neutral equilibrium? Potential energy remains constant. So this is the equilibrium that I like. You always try to come to this position of neutral equilibrium. No one can displace you. You're at the top, but you're not alone there. You're not at the top of the hill. That's how you will fall down. You are on the top of the hill, but it's a flat surface. You will not go down. You will just remain on that surface, whatever happens. Neutral equilibrium is the equilibrium that I want, not the stable one. I want the neutral one. That is good for you in life, to have neutral equilibrium, not to have stable equilibrium. Okay, then you move on to the third point. I hope you have written it out. Force has to be 0 in all the three. There is no point of discussion on that. Force, which is the negative gradient, has to be 0 here. It has to be 0 here. And it has to be 0 here as well. There is nothing that we need to understand here. Now, the fourth point that we are going to understand is basically maths, and it has got nothing to do with physics. And that is something which you will study in standard 11th, something which is known as maxima and minima. Now, this maxima and minima are concepts taken from maths and applied in physics. As I always said, mathematics is the language of physics. If you don't understand maths, if you're weak in maths, physics is gone. There's no chance with physics. Maxima, minima. What is maxima? What is minima? Maths is also simple. I mean, it means what it says. Maxima means maximum, minima means minimum. So there is a test that you can do in maths to find out whether any function is at its maximum or it is at its minimum. I will not go into that, how it is done, because that is purely maths. And I don't have that much time. Probably in the break between 11th and 12th, I will take some class on maxima minima, and I'll tell you what is maxima minima from a physics point of view, not from a math point of view. Okay, so maxima minima, two things, maxima and minima. I'll do a question on this. Don't worry, you understand what is maxima minima. So, as you can see here, the important point here is potential energy is minimum. Oh, wrong color. I should not use wrong color. How do I do it? I erase it. Okay. Okay. Maxima and minima, what you can see here is potential energy is minimum. I hope you can see this. Potential energy is minimum. Now, to have minimum potential energy, two things must be satisfied. The first thing is du by dx is 0. That is number one. To have a maxima or a minima, two things must be satisfied. Number one, du by dx is 0. Number two, d2 u by dx square, the second derivative has to be positive. This is the condition for a minimum value to occur in maths. This is maths, this is not physics. This basically means whatever we have written, that the rate of change of du by dx is positive. The rate at which energy is changing is positive, then that means that the potential energy will come to a minimum. Do we understand this? Yes or no? This is all maths. This is all maths. You just have to remember it. This is all maths. You just need to remember it. That is the only thing that you can do. I'll give you a question on this. Don't worry. And we will try to find out whether it is maxima or it is minima. So far, so good. What are the conditions for minima? Number one, du by dx has to be 0. Number two, d2u by dx square must be positive. That is the condition for a minima. Now, if that is the condition for a minima, what is the condition for a maximum value to occur? This is all math, nothing to do with physics. First condition for a maximum to occur is same. First condition is same. Du by dx has to be 0. I can't change that. But the second condition is different. The second condition is d2u by dx square. I'm always saying y. d2u by dx square has to be negative. That means the rate of change of du by dx is negative. I'll not go much into that, because it becomes more of a maths class rather than physics. I must concentrate on physics. Maxima, minima. Now for a neutral equilibrium, here du in first case second derivative is positive, in second case second derivative is negative. Positive, negative both are done. So in the third case what happens is it has to be 0. So rate of change of du by dx is 0. This is easy to understand. U should not change. So the rate of change of du by dx has to be 0. You have to be on a flat surface. If you are on a flat surface, you are in the state of minimum. You are in the state of neutral equilibrium. Your energy does not change. I hope this is all clear. I will give you example on this. Don't worry. Let me just go through this last example, and then probably I'll give you an example on maxima and minima. And that maxima and minima will cover a lot of things. So don't worry, I'll do that. If there's something that you don't understand, I'll try to bring in some examples and make some sense out of it. And the last of this was simple. The illustration of this entire concept. This is the condition of stable equilibrium. If I move it here or here, it will always try to come back to its original position. Why it will try to come back to its original position? Because of the restoring force. Restoring force will act, and that force will force this particle go back. You are not supposed to be here. Go back. In case of unstable equilibrium, you are on the top of the hill. Once you fall down, everyone will fall back. No one will be supporting you. You will fall down and you will be pushed away. Someone else will take your place. I don't want you to be in this position at all. What I like the most is this one on a flat surface. No one can push you. Even if someone pushes you, you are still there. 3 examples. Stable, unstable, and neutral equilibrium. I'll give you a minute to think about it. If anyone has any doubts, anything that you have not understood, I'll give you a minute. Think about it. Let me know if I can help. 1 minute. Well, if there is no doubt, then I must move ahead and solve some question. The first question that we are going to see in this particular case is problem number 32. And it's a pretty straightforward problem. I don't think you will have any problems dealing with this one. Remember, you only get to read the problem once in the examination hall. Read the problem once, understand the important points, and solve the question. I will mark the important points that you must remember while reading that question. So The question goes like this: potential energy. So potential energy is given by the function a minus bx square. X is the displacement. Instead of calling it a displacement, it's better to call it the position of the particle. What is the magnitude of force? So basically, potential energy is given. You have to calculate force. This is a question taken from BHU. Now, BHU at one point in time, during my time, it was not a IIT, it was just a college of a university, and it had its own entrance exam. This is taken from that entrance exam. So the potential energy is given, and you are supposed to find out the force acting on the particle. You are given 4 options. It's a very straightforward question. Can you tell me what is the answer? Energy is given. These are the type of questions that will come simple, straightforward in JEE Main. What we have done, this stable, unstable, neutral equilibrium, these are all questions for JEE Advanced. Will come. So you'll hardly find them in JEE Mains. Okay. Problem number 32. Anyone has an answer for this? Potential energy is given. You have to find out force. How will you find out force or potential energy? Try it. It's a straightforward question. No idea? Well, it's very simple. I hope you have all done the wrong color. I must not use this color.
The energy with respect to x.
Yes, it is very simple. Now, remember, don't differentiate it. Also put a negative sign. This negative sign is very, very important. Do not forget this negative sign. Is negative gradient. Remember that. So just differentiate energy with respect to time with a negative sign. Here I differentiate it. I get 2 times bx. 2 and b are constant. So force is directly proportional to the displacement or the position. So the option is option number B, proportional to x, and that is how you have done it. Do you all understand this? Can I have some raise hand that you understand this? Girls on the right, backbenchers. Okay, everyone is there. Good. Simple. See, these are the sort of problems that will come in the examination hall. The problems that will come in the examination hall are pretty simple, and the question that we are doing in the class are pretty tough. That is why you will find the paper always easy. Problem number 33 is the next one. I'll read it. Again, remember, you only get to read the problem once. Read the problem once, understand the important points, and then solve the question. The potential energy is represented by the first figure. So this is the graph of energy versus position. What is the force acting on the system? So that is the important point. Potential energy graph is given and you are supposed to draw the force graph. One graph of potential energy is given and 4 different graphs of force is given. You have to tell me which graph matches it. 1 minute. You must be able to do it. Anyone in the online class, offline class, Kevin, Shashank, Manasa, I hope you are trying to solve the problem. Online, offline, anyone with an answer for this one? A, B, C, D. What is the answer? A or B or C or D? And the reason behind it, let me change the color of the pen. Let me get it to red. Okay. Tell me, what is the answer? A, B, C or D?
C, sir.
D.
C.
C. Right? C is the correct option. Well done. Tell me how it is C. Why it is C? How and why? Answers don't matter. Answer you can see from here. You can see C here. So answers don't matter. What matters is whether you have understood the question or not. Tell me how it is C. Why it is C?
Slope is positive, then its distance is 0, sir.
आवाज बड़ा.
If
Yeah. Tell me.
slope is positive, then its distance is 0, sir.
Sorry. Just speak loudly, beta. I am not able to hear you. Let me get my volume up. Okay. My volume was down. Okay. Now tell me.
If slope is positive, then distance is 0, sir.
If slope is positive, then distance is 0. No, I don't understand it. Slope is positive. Okay. So you are talking about this slope, right? Slope of the energy graph is positive. That is what you are talking about? Okay. This slope is positive. I understand that. Okay. What does that mean? Slope is positive. One more thing with this slope, this force is positive. I mean, this slope is positive and this slope is constant. Do we all understand this? That this slope is positive and this slope is constant. It's a straight line. Straight line ka slope is always constant. So looking at the slope of this energy graph, the slope is positive and slope is constant. Slope is positive, slope is constant. Now, the slope of this graph, if I do the negative of that slope, negative of that slope will give me force. Now, slope is positive, so negative of that positive will be negative. Negative of positive is negative. That means force is negative. Force is negative. Do we understand this? Force is negative. Because the slope is positive, therefore negative of positive is negative. Slope is negative. Looking at this, it is constant, so force is also constant. So if I call this point as O and if I call this point as A, from O to A, slope is positive and constant. Slope is positive, therefore force is negative and force is constant. Now I have to look for a graph. Where force is negative and force is constant. Looking at the graph number B goes away, graph number D goes away. The only graphs that are in contention are A and C. Now there is a difference between A and C. Up till here, both the graphs are same. But after that, the graphs are different. So let us check which graph is correct. Now I look at the portion from A to B. This is A, this point is A, and this point is B. From A to B. If I look at the graph from A to B, the energy graph, it is a straight line parallel to x-axis. That means here slope is 0. It does not change. Slope is 0. If the slope is 0, that implies my force is also 0. So I've got one more information that from A to B, next point, force has to be 0. I look at this graph, I find out that the force is there. So this graph goes away. The only graph that remains in contention is graph number C, and hence the answer is C. Do we understand that? Can I have some raise hand that we understand this? Students in the left, guys on the left, guys at the back, girls at the left, girls at the right, girls at the back. We all understand this? Understand the logic? Answer will already come. Answer will always come. Don't worry about the answer. I'm not worried about the answer. Understand the logic. These are the type of question that will come to you. No question will be straightforward. No one will tell you this is energy, find out force. Hardly you will get that question. You'll always get question based on the concept. They will check your concept sometimes. That is how problem number 33 has to be done. I'll give you a minute to note it down. Then we'll move on to the next problem, which is problem number 34. A minute.
This is,
Yes, beta.
sir, this is like a first case, right, sir?
This is like the first case means
Stable.
and no force. Yeah, from A to B, it is equilibrium. So then, what are you talking about? What is the first case? You're talking about stable equilibrium.
Yes, sir.
We have to find out whether the equilibrium is stable or not. We'll find it out. Don't worry. To find out, for that you have to find the energy function. Take the second derivative. Force. See, if you are talking about, let me just come back to this. Let me come back to this. Okay, tell me. We are talking about graph C. So you think that this is stable equilibrium. What makes you think that this is stable equilibrium?
Positive slope you said, right, sir? So
Hmm? See, equilibrium only happens when force is zero. So in this portion where you have force acting, there cannot be equilibrium because the force is acting. Here also there cannot be equilibrium because force is acting. Here also there cannot be equilibrium because force is acting. Equilibrium can only happen when the force is zero. So in this case, equilibrium can only happen from this point onwards. In this case, equilibrium can only happen from this point onwards. In this case, equilibrium can only happen from this point onwards. In this case, equilibrium can only happen from this point onwards. Do you understand this, what I'm saying?
yes, sir.
Now tell me what is the doubt.
No, sir. No. Clear, sir.
Got it?
Yes, sir.
For equilibrium to happen, force has to be zero. Force is constant. Equilibrium cannot happen. There is force, beta. The first condition is force has to be zero. Don't worry, I'll give you a question. Don't worry. Just relax. Let us solve the next one. I'll give you a minute again. If anyone has any doubt, this is a very good doubt. So if anyone has any other doubt, please come up. We have time. Don't worry. I'm not running for time. Now is not the time to run for time. If you've understood this, then I'll move ahead. I'll give you a minute for everyone to ponder on this online class as well as offline class. Please let me know if there's any doubt that you have.
Let's scroll up, sir.
Okay. Have we noted it down? Shall we move ahead? The next problem. Okay, here comes the next one, which is definitely problem number 34. It's a straightforward question. You can expect such a question in the exam. This is the sort of question that are likely to come. Question number 33, question number 34 is also come in JEE Main, I think in the year 2019 or somewhere. Anyways, similar question keeps on coming. A particle moves in a potential region. Energy is given like this: 8x square minus 4x plus 400. What is the state of equilibrium? So we have to find the position of the equilibrium. Where does equilibrium happens? Once you solve this, then I will add one more question into it to make you understand what type of equilibrium this would be, and then probably things will be more clear in your head. First of all, tell me, where does the equilibrium happen? I will give you a minute to deal with this. I hope students in the online class are also following the lecture. Please raise your hands that you are following it, so that I understand. Yes, Manasa is there. What about Kevin and Sashank? Are we there on the same page, beta? Kevin is there. Well done, Kevin. Okay. What about Sashank? Sashank, are we there in the class? You following me? Is there anything I can do for you? Okay, I think I've lost. Yes. So, okay. Okay. Well done. Chalo. Simple question. 1 minute. If you can solve it on your own, I would be pretty happy. If you solve the first question, that means the concept is clear. Nothing more needs to be done. Well, anyone got the answer? Well done. Can anyone tell me how it is done? Straight away, it's there in the sheet itself. How it is done?
Sir, here potential energy is given.
Yes. Go slow, na. I'm not as smart as you are. Just go slow, na. Give me time to reciprocate. Okay. Really, my brain is deteriorating. It's not as fast as yours. I am on the old Pentium processors. You are on i7 and i9. So just go slow. Okay, tell me. Yeah. Energy is given so?
And differentiating the energy with respect to x gives us the force.
Have you missed a point here? Differentiating u with x. I told you don't forget that point.
On the minus.
Yes, that minus is important. Okay, you differentiate a u with x and put a minus sign, you get a force. Well done. So what do you get after doing that? You get the derivative of this, and the derivative of this is, I think,
Equates to 0.
minus 16x plus 4, right?
Yes,
That is the derivative.
yes, sir.
Okay, what is that? That is step number one. Well done. I have differentiated it, found the negative of that derivative. That is step number one. That gives me 4. What is step number two?
Equate it with 0.
Equate it with 0. So that is what I have done here. I will get the value of x. X becomes 4 by
1 by 4.
1 by 4. Yes, for me, 1 by 4 is good enough. I will not go any further. X is 1 by 4. Now you can match which option it matches. I think it matches with option number B. And hence option number B is the correct option. Everyone got this? Can I have some reason that we got this? Okay. And as I said that I will add up a question for you to understand how things are done. You have an equilibrium, right? You have an equilibrium happening at x is equal to 1 by 4. Everyone understands this?
Yes, sir.
Now the question is, what type of equilibrium it is? Now, as soon as I get into that question, that becomes a question of JEE Advanced. What type of equilibrium it is? Three types. मैं से कौन सा? Which one? Stable or unstable or neutral? I'll give you a minute to think about it. I will be very glad if you can do it on your own. You have to tell me which type of equilibrium this is.
Unstable, sir.
Unstable. Okay, I have an answer. And now I will have to ask the question, how did you get it?
Because here the force is negative.
Force negative means unstable equilibrium. Did I ever tell you that? Did I ever say that if force is negative, the equilibrium is stable or unstable? No, I did not tell you that. Don't rush for answers, beta. If you rush for answers, you will make a mistake. Don't rush for answers. Think, think, think. Go back and see how do you find stable or unstable equilibrium.
Sir, it is at a height, sir.
It is at a height, sir. How do you know it is at a height?
At 0.25 meters.
0.25 meter does not 0.25 meter does not mean height. It can be on the x-axis as well. This is actually a force acting on x-axis, so it is at a distance of 0.25 meter from the origin on the x-axis. How can you say that it is on height? You are making guesses. Remember, beta, we are not playing kaun banega crorepati that you can guess. Physics is not kaun banega crorepati. It is about logic. It is about sense. Even KBC is about sense, but you can go ahead and make some intelligent guesses and probably win a prize of 25 lakhs there. Not here. There has to be a logic. There has to be a logic. You're not looking at the logic. I'll give you a minute. I'll give you a hint while I give you that time. So I'll take you back in past. No, it's impossible in physics to go in past, but here I can go to past. Now I've taken you to the past, and this is the past. This is how you find out which type of equilibrium it is. I'll give you a minute to think about it.
The rate of change is 0.
How did you get it? You're making intelligent guesses. Intelligent guesses won't work. Tell me the process. No one is telling me the process. Everyone is hell bent on giving me an answer. And
d
I
by dx is equal to 0.
is it? No, it is not. We're rushing for answers. That is the problem with most of the students, not you, everyone. Everyone looks for the answer. Let us get the answer first. No, get the logic first. Look for the logic. Watch Three Idiots if you want to have some inspiration. Look for the logic, not for the answer. It does not say in Three Idiots. My concept is different. Don't go for the answers. Go for the logic. If your logic is correct, your answer will come. Nothing can stop you from getting to an answer if the logic is correct. Okay, shall I do it? Okay, don't worry, I'll do it. You forgot the steps. To find what type of equilibrium it is, I have to do stepwise. Step number one. Step number one. I find the first derivative, du by dx. And that du by dx has to be equal to 0. Du by dx has to be equal to 0. If I find du by dx, it will be equal to 16x minus 4. That is du by dx. That is equal to 0. From here, I get x is equal to 1 by 4. That step has already been done. You don't need to do that again. Step number 2, which no one thought about, or even if you thought about, you did not execute it correctly. Then I find the second derivative of u, d2u by dx squared. How many of you thought about this step? Please raise your hands. How many of you? Only 1, 2, 3, 1 at the back, 4 at the front. Okay, if you thought about this, well done, you are on the right track. I find the second derivative of u. Manasa also tried it. Well done, Manasa. I differentiate it once more. Remember, I differentiate this thing once more. I differentiate this thing once more. I get 16. 16. 16x minus 4, ka derivative 16. This 16 is positive. Second derivative is positive. Let us go back in the past again. Take our time machine. Doraemon has a time machine. We are using the same one. We take that Doraemon time machine and we go back. My kid watches Doraemon. Doraemon has a time machine. I take that time machine, I go back. When do I go back? And I find where is the second derivative positive? Second derivative is positive. That means the equilibrium is. What is the answer now? This is the past. Let us come back in the present. What is the answer now?
Stable, sir.
Yes, the answer is stable. Now the answer is correct. Why the answer is correct? Because your logic is correct. We have thought about this thing logically using maths and physics at the same time. This is a condition of stable equilibrium. So this unstable equilibrium is definitely wrong. Something is wrong, I can't keep it here. So I'll just remove it. And that is the answer that we were looking for. Do we understand this, or it is too tough for us to understand? Please raise your hands. If you understood this, please raise your hands. Everyone, I'll give you a minute to think about this. I'll give you one more question to make this point more clear in your heads. Note this down till I get the other screen up and running. Please note it down. I'll get the other thing running. I'll get it. I hope you are noting it down. If you have done this, well, we will jump on to the last problem for today's class. And here it comes on your screen right now, right away. The energy graph or the energy function is given as 18x minus 6x squared plus 5. And the question simply asks you, find the points of equilibrium. Remember, maybe in the next class we'll do it. Remember, the question that we are doing now only has one point of equilibrium, but you can have questions where you have 2 or 3 points of equilibrium. That probably I'll do in the next class. Right now it's only one. Find the points of equilibrium and which and what type of equilibrium it is. Your time starts now. Don't rush for answers. Answers will come. Go for the process. That's more important. A minute to win it.
Sir,
Yes, beta.
x is equal to 3 by 2, sir.
3 by 2. That is the point of equilibrium. Yes. What type of
Unstable
equilibrium?
equilibrium, sir.
It is?
Unstable equilibrium.
Why?
Sir, I am getting stable, sir.
Okay, someone is getting stable, someone is getting unstable. It cannot be both. Someone has to be right. Someone is not right at this point in time. But remember, right and wrong only depends on your reference. Probably you have done something not correct. Okay, shall I solve the question now? First, let us try to find the points of equilibrium. So to find the points of equilibrium, I have to find du by dx. Du by dx has to be equal to 0 for points of equilibrium. That means I differentiate this. If I differentiate this, I will get 18 minus 12x. Everyone got this? I will not go into how I differentiated it. This is pure maths. Everything is pure math. There is no physics over here. But it is interesting maths. Whenever maths and physics come together, it just becomes very interesting. 18 minus 2x, 12x is equal to 0. That must be equated to 0. From here, I will get the value of x, which is the point of equilibrium as 3 by 2. No points, no questions asked, no reasons given. That was my first step number 1. Let us move on to the second step, which is step number 2. How do I get to this step? Now, to get to this step, I must find the second derivative d2u by dx squared. I find the second derivative of this thing. So basically, I got to differentiate this, which I'm marking in green. I have to differentiate the first derivative once more. So I differentiate this once more. If I differentiate this once more, what do I get? I get minus 12. That is the only possible result that I can get. Now this minus 12, as you can see, is negative. Second derivative is coming as negative. That means this is maxima. And that means that this condition has to be condition of unstable equilibrium. This condition has to be a condition of unstable equilibrium. Do we understand this? Can I have some raise hand that we understand this?
Sir,
Yes, beta.
Sir, we need to take minus du by dx, no, sir.
Minus du by dx is force, beta. I did not ask you what is force. I asked you what type of equilibrium it is. Why you are taking negative? Negative is only for force. If I would have asked you find force as a function of x, I will ask you that question as well. So I'll add up a question here. Find force. Find the force on the particle. Then what is your answer? So give me the answer here. What is the answer here? What is the value of force? Give the answer here. Force is negative of the derivative. So the answer here for force is, who will give me this answer? Answer is 12x minus 18. Now, if you differentiate this one, you will obviously get plus 12. But you can't differentiate this. You have to differentiate this. Do you understand this?
Sir,
You have to find the second derivative of energy. You don't have to find the derivative of force. Remember, force is negative derivative. It is a negative sign is added there. If you find out force and then find the derivative, you'll always have the ulta answer, not the Sida answer. Getting my point?
yes, sir.
That is what you need to remember. That is why you need to remember there is a negative sign. That is why you need to remember that you put a negative sign, that gets you the force. But to find the points of equilibrium, you have to go to du by dx, not for to force. If you go to force, your answer is ulta, always ulta. Got my
Yes,
point?
Yes, sir.
Well done. That was one point that I wanted to make, and I'm glad that you brought it up. So that this point is clear. Don't differentiate force and get the equilibrium, because then your answer will be ulta, reverse. Find du by dx, then differentiate du by dx. Don't differentiate force. Force is ulta of du by dx. Force is the negative of du by dx. Don't differentiate that. Differentiate du by dx. Am I clear? Can I have some raise hand that we understand this? Okay, if you have understood this, congratulations. This is a topic that is only likely to come in your JEE Advanced, and I hope that this thing comes and you can score some marks here. If this question comes, it will again be a question that would be coming as a multiple choice rather than a single option correct. That will give you more added advantage. On that note, I will end today's class. I've taken 3-4 minutes extra, but was important that I discuss this point. Remember, in today's class, we have discussed the points of equilibrium, but we have only seen that there is one point of equilibrium. Is that the only case? No, that is not the only case. There can be even infinite number of points of equilibrium. We will not be doing a question of infinite points, but I will try to do. No, we will do questions where you have 2 points of equilibrium at least, so that you can find out which equilibrium is what. That we'll be doing in the next class. I'll wait for that class. I hope you also wait for it. Today's class, I think it is all over, and I dismiss it at this point in time. I hope you had a
Sir.
nice time. Yes, beta.
Sir, can you discuss the test paper in next class?
Can I discuss?
Test paper, sir.
Okay, test paper. I do not get that test papers. You want to discuss it? We'll discuss it only.
Sir, we have some doubts.
Okay, so you can ask me those out, and we'll discuss it. So give me a list of those doubts. We'll discuss that question. Not a problem. Okay. Anything else?
Bye. Bye, sir.
Okay, so we'll meet in next class. We'll discuss the question paper if you want to, and we will go ahead with this topic. Class is over from my end. If there's anything that you want to ask, go ahead.